Hey everyone, welcome back to another episode of the Weekly Coder. I'm Chris, and in this episode we are going to continue on with Conway's Game of Life. Now, initially I thought we were going to do a three-part series and be done with it, but I realized that after I finished the three-part series, I kind of played around with it myself a little and decided, you know what? We're going to add some more stuff to this because just the way we left it is, you get the basics, you understand how to implement something like that in Unity, but I didn't really take you any further than that. I didn't give you more tools to kind of make it your own, right? I mean, you could, but it's easier when someone shows you how, right? And that's what these tutorials are all about, is to show you how to get things done. So, with that said, the first thing I want to do is I want to show you what we're going to eventually end up with, okay? And I'm going to demonstrate that using a website. And you can go there yourself if you want, and basically it's just theweeklycoder.com. And I don't know if any of you have actually been to my website. I don't really do much on here anymore, other than, from time to time I'll list a project or do a blog. I mean, you can look at this last blog update, it was forever ago. I do have a store where I list source code for sale as well. And then I've got links to my YouTube channel and Twitter and Patreon and that other stuff. So here I added a page called Projects, which I'm probably going to be adding more to, but for now we have Conway's Game of Life. And basically the way I'm going to do these projects is anytime I do a new project on YouTube, you can bet that I've already gone through and kind of created it myself. So I have a final product of what we're going to end up with. So as I do with this. So Conway's Game of Life, what we are going to finish with is, if we click on this now, you'll see that this is loading a WebGL version of our Unity project. And so that can be achieved by doing the WebGL build in the build settings, and I'm going to go over all of this and how all of it works. So basically the way that you do this is I set it up so that you can press L, and that opens like a little load dialog, and it pulls from a directory that we specify, and that directory has a list of patterns that we decided to save. So one of them is this pentamino right here. So if we load that up, you'll see the shape that it loads is a pentamino shape, and from here we can press the B button and that'll start that simulation. So that's a lot more fun to do than your typical kind of what we did previously, was to just kind of randomly set certain cells to be alive and certain cells to be dead, and then just kind of at random created this simulation, right? So we can pause this whenever we want. We can press P and it'll pause it right where it's at, and we can, if we choose to, we can say, hey, you know what, we want to save it here. If we press S, and then we can just give it a name, or if we want to edit it, we can click into any one of these grid cells to set specific cells to be alive or dead. Okay, so then we can save this if we want, or we can just resume by pressing B, and it'll start that simulation from where we saved or made the last changes from. So not only will I be showing you guys how to basically set it up so that you can edit the patterns however you see fit, which is actually the first thing we're going to do, and this is going to be today's tutorial, is we're going to basically create this grid, and yeah, that's it, just create the grid, because that's already a lot of work. So we're going to create the grid, and from there, after that, we are going to have to work on detecting mouse clicks to be able to tell where we're clicking so that we can put a cell in the right location. And then what we're going to work on is creating a load dialog, a save dialog, and after we're done with that, we are going to learn how to export a WebGL project and also be able to utilize saving of files and loading of files. And basically the way we're doing that is we're going to serialize and deserialize our object that is going to store all of our actual like cell data. So there's a lot of fun stuff that we are going to be doing in the next couple of weeks. More than few weeks. It's going to take a little while to get to this level. So next project, this project is going to be just the grid. The next project is going to be just detecting the mouse clicks. The next project after that is probably going to be saving. And then the next project after that might be loading. And then the next project after that might be exporting. So like I said, there's a lot of cool stuff to come. So hopefully you guys enjoyed this little demo here. I think we need to go ahead and jump into the tutorial so that, I think we've already wasted enough time just playing around here, but, you can get lost in this stuff, right? So, the first thing I want to kind of throw at you guys, and I'm terribly sorry about this, I usually don't do this, is this game class is not going to look exactly the same as we left it, because I added some stuff in here. I added a parameter that we can specify for place cells, and that parameter basically specifies if we want to have a type 1, type 2, or any other type. And basically what I did here is, that was before I actually decided, you know what, I'm going to make it so that I can create my own patterns, is I figured, you know what, we're going to do it in code. We're going to create this pattern in code, and this is what I did. Is I created this one pattern here, and it's basically just a for loop, and it starts at a specific spot, ends at a specific spot, and just kind of lays out this pattern here. And that is what happens if you specify the type equals 1 when you go up here in the start method. When you start with place cells, you specify 1, and then it starts to load this type of pattern. In here, if we specify 2, it does the random, and if we specify any other type, it's going to do none. So we're going to leave it at 1 while we create the grid. And so the first thing we need to do is actually close this and get this out of the way, and we're going to create a new script, C# script. And we're going to call this grid overlay. You could do this in Photoshop, and that would probably work for a little while, but it wouldn't be as cool as doing it in Unity. Plus, doing it in Photoshop will, limit you to whatever size you make it, and it's just not going to be as cool, right? So the first thing we're going to do in this method, or class, is we're going to get rid of these methods, because we don't need them, and we are going to, we're going to talk about something for a minute. And I know I've done a lot of talking, and it's because we're getting into some new territory here, something that we haven't covered at all, ever, in any of the tutorials that I've done. And that is creating material from scratch. Also using GL to actually draw lines. So all of this entire class is going to be a new experience for, well, me. One, I learned a lot, and two, you guys, if, I'm sure that you also follow along with other tutorials, and if you don't know anything about this yet, you might learn a little bit. Keep in mind, fair warning, I am not an expert when it comes to shaders. I am not an expert when it comes to creating materials. I don't consider myself an expert in those areas at all. Drawing things with GL is not something that I am an expert at. I have had very, very little time learning all of this stuff. Most of my experience comes in the form of being able to, follow a very logical sort of process when creating code, and just kind of working out the logistics of the code that needs to be written and figuring out problems and that kind of thing. When it comes to shaders and having to know that specific syntax or the macros that are being used, the properties that need to be set for certain shaders, the blendings that need to happen, I don't know a lot about that. So I did look up some of this stuff on Google to find what I need to use in order to be able to draw lines, right? So I'm gonna, try to explain the best I can, but take anything I say with a grain of salt with regard to shaders. and do your own research to make sure that it is, you know, that I'm giving you accurate information. So, fair warning. The first thing that we need to do is we need to actually create a variable, and that's going to be of type material. And we're going to call this line material. And basically, this is going to be the material that is going to be used for the lines that we draw using GL. Okay. The method that we're going to use is create line material, and we're gonna put this in its own method because we want to call this when we when we want to draw, right? When we want to draw our lines. So the first thing we do is we check to see if line material has already been created. So we say if not line material, right? Line material is nothing. We are going to need to set a shader for this line material, so we need to create one. And to do that, we use the shader class, and we're going to use the find method to load up this shader called internal colored. And that's what's going to be used to actually give our lines the color that we need. We are going to set, basically we're going to instantiate a new instance of line material using the material class constructor, and we're going to pass in the shader variable that we just created. The other thing that we need to do is we need to set the hide flags for line material. And the hide flags are basically to create this as a scriptable object, and it's going to be hidden from the scene, and we need to set hide and don't save. So basically what that does is it kind of hides it, to the best of my knowledge anyways, it hides it from the garbage collector so that the garbage collector doesn't come through and basically say, hey, well, this isn't being used, so I'm going to go ahead and clear it from memory. So we don't want that to happen. And with that, we're going to create a method, and not create a method, but we're going to call an inherited method on disable. Whoops. And what's going to happen here is we need to destroy immediate line material, because if we set these flags here, hide and don't save, preventing the garbage collector from doing its job and clearing things from memory, then we are going to continuously retain that instance of line material, even if we have this disabled and don't need it anymore, in which case we should clear out that memory and we shouldn't retain that instance, because it just, takes space where it doesn't need to. So instead of letting garbage collection happen, which we're disabling by adding that hide and don't save, we are going to have to manually destroy that object. So we do that on disable. Okay. So the next thing that we need to do is we need to make sure that we set our that we turn on alpha blending. Okay, and this is the part that just kind of I don't really understand a whole lot, so I'm just going to write this stuff as I found it, and it all works, so we're just going to go with that. To me, it basically is looking like we are setting properties of this shader specifically that are available to us, and we're going to set specific values to those properties. And Unity Engine, apparently, the rendering class specifically, our namespace, blend mode, has some predefined values for us to use. And so I can tell you that I did read up some on this, because I don't like to blindly just use code and absolutely not understand what I'm doing, because I just like to question things. So here we go with blend mode, and here we're going to use 1 minus source alpha. In order to use, since we're using alpha blending, apparently we have to turn off the Z-write depth writing. So we do that here again in the material set in, and then that's Z-write, and we're just going to set that to 0. And then we also have to turn off backface culling. And I'm guessing that that has to do with, I don't know if we actually have to turn this off or not. You know, sometimes when you use other people's code, they put, I think, a lot of unnecessary things in that we don't need. So one of the things that I'm going to do while we're doing this video is I'm going to write this as it is, and then I'm going to, when we are done, when we're running it, I'm going to just comment that line out and see if we need to actually turn off backface culling. It's very possible that when I found this before, that this was used to draw lines not just in the X and Y direction, but maybe also in the Z, which would explain why they would need to have alpha blending enabled. In a way, I think, because if you're looking at a cube, you need to be able to see all that. Maybe? Alright, so like I said, not a graphics guy. The next thing we need to do is we need to call another inherited method, and that is the onPostRender. Okay. So onPostRender, it gets called after render, and the first thing we're going to do here is we're going to create line material. And I should have probably looked this up, because I don't know what this means either, but line material set pass equals 0. How many passes we're going to make? I have no idea, maybe. gl.begin, and that is self-explanatory, meaning that we are going to begin, and we're going to begin a context of drawing lines. With that, we also have a gl.end that we have to specify, so I'm going to go and do that so we don't forget. And then our code's going to go here in the middle. So everything that we're going to draw, it's going to be here. So you have to kind of wonder how we're going to construct this grid, right? You're not going to just go and write code and be like, I'm going to draw a grid, and it's just going to have a bunch of lines going up and down and left and right. So one of the things you have to think about when you create this, right, you have to wonder in your mind how this grid is going to look to you, right? Let's suppose that we have a 10 by 10 area that we're working with, right? That's going to be our grid. And we want to subdivide that out into units of 1 so that every 1 unit is a block in our grid, right? So that would give us 100 blocks altogether, meaning from left to right we've got 10, up to down we've got 10, and 10 times 10 is 100. So if we have 100 blocks, forget that for a second, let's say we have 10 squares. That's not a lot of squares, but if we multiply that and say that our grid is now, instead of 10 by 10, is 100 by 100, that means we have 100 across and 100 up and down. It's really tough to look at when you've got that many squares. So a lot of times it's easier to break them up, right? You can subdivide those out further and say, you know what? Let's make it so that every 10 squares we draw a line that's just a little thicker or a little darker or just a different color altogether, just so that we can see a clear line of separation between every 10 squares. So that'll make it easy for us to see, hey, this is 10 squares, this is 10 squares, this is 10 squares. That's easy, right? That's easier than saying about how many squares is this. So I mean, you could look down straight down the center and say it's 50 and divide that again to 25. But still, it's easier to have some like visual aids to guide you, right? So when I create this grid, the way I want to do it is I want to be able to have those, the main lines, right? And then I also want to have subdivision lines that we can set up. So what we're going to do is we're going to create some variables. And these are going to be public so that we can manipulate them in the inspector. And they are going to be just booleans, and they're going to be a show main. Right, these are the main lines, and we're going to set that to true by default, and then a show sub. We're going to set that to false by default. And then when we set up our grid, right, there are a couple of things that we need to know about our grid. We need to know, first of all, our grid class needs to know how big should I be? right? How big? What is the grid size, right? So how many squares are there going to be? So we need to basically be able to give those values. So we're going to do public, and that's going to be an integer, and we're going to do grid size x and grid size y. The other thing we need to know is where is the grid going to start in relation to our grid, right? Where do the lines start? So we can do that by specifying floats, and we're going to say start x and start y. So the other, we also going to need a start z, and that's just, you know, you don't have to pay a whole lot of attention to that, but it does need to be there because the part of the method that we're going to use to draw using GL needs a z value, so we'll just let that be 0. Because z for our purposes just does not matter. So now that we know our start position and the size of the grid, we need to now know what our step is going to be, like how many lines, right? So how big is it going to be? 1 unit? Is it going to be half a unit? Is it going to be 2 units, 10 units, what? So the cool thing is we can do this. We can say public float let's call this small step, and then we're going to do 1 and we'll call it large step. So what that's going to do is it's going to enable us to say, okay, for every maybe let's say we have 100 across, right? So we want our squares to be 1 unit exactly. So the small step value, we would then set that to 1, and then we want a subdivision at every 10, so we set our large step to 10. And those values will be very, very important in just a second when we actually start fleshing out our onPostRender method. In between these GL begin and ends, that's where we're going to put our for loops. So in here, the first thing we're going to want to do is we're going to say, hey, do we want to show the sub, okay, the sublines, the subdivisions. And then we also want to check if we want to show the main, because it could be that we don't want to show any. We'll just turn the grid off. So the first thing we do in show sub is we're going to set the actual color that we want to use, right? So we didn't create those variables, did we? Nope. But we should. We should set. We should create some variables. So we're going to create a color, and we're going to make it public so that we can manipulate in the inspector. So we're going to do public color, main color, and we're going to set that. Let's set that to a green. Let's do 0f, 1f, 0f, and 1f. So 1f at the end is the alpha, so that's fully opaque. I do know that. Main color, let's do subcolor, and that we're going to make a darker shade of green, or is that a lighter shade? That should be a darker shade. So that would be 0.5f, 0f, and 1f. Okay, so now we've got our color variables. We can set those in here because we have to set the color before we start drawing. So we're going to go with gl.color, subcolor. So that's where we're setting the color. And then if we do show main, we're going to do gl.color, main color. Okay, so hopefully everybody's still with me, and it should be easy enough up to this point. And it's not going to get much harder, actually. The only thing we have to do now is we have to actually write the for loops that are going to iterate over the y-axis and the x-axis to basically draw our lines. In order to draw a line, we have to pass in 2 points, an origin and a destination. Okay, so once we pass in one point and then we pass in the next point, GL is going to draw a line from those between those 2 points. Okay. So what we'll do is we are going to say for float y, so we're going to iterate over y first, equals 0. It's less than or equal to grid size y. and then y plus equals small step, because remember this is the subdivision one. Sorry, I kind of got lost there for a second. So yeah, the sub is the small step. Is that right? Yeah, we're good. We're good. Okay. So from here, for every y, we're going to GL vertex 3. We're going to pass in a vertex point, right? And we're going to start with start x, and then start y plus y, and then just do start z. And then the next point is going to be vertex 3 again. Start x, that'll be plus the grid size x, and then start y plus y, and start z. Whoops. So just real quick, what we're doing here is we're setting the starting point, start x, which is probably 0 to start with, start y, which is also 0, and since y right here is 0, plus 0 is also 0, so our start x is 0, start y is 0, start z is 0, so our first point is 0, 0, 0. And then our second point is going to be start x, which is 0, plus grid size x, which is going to be 64. 64 plus 0 is 64, obviously. Start y plus y is still 0, start z is 0, so this will be 64, 0, 0. So we're going to draw a line, right, along the x-axis from 0 to 64. Sorry. The next iteration around, the only thing that actually changes here is going to be the y, because the y is the only thing incrementing. X does not change at all. So we're still going from 0 to 64, but y is now going to be 1 and 1. Okay, on both ends, right, of the x-axis. We're just going up by 1. We're drawing horizontal lines. So to draw the vertical lines, we're going to iterate over the x-axis. Okay, so x, remember, goes from left to right, less than or equal to grid size x, x plus equals small step. All right, so gl.vertex3 is going to be start x plus x, so basically the opposite of what we did for y. And then we're going to have start x, or sorry, start y, and then start z, start z, and then we're going to give the second point, which is going to be start x plus x, sorry, start x plus x, and then start y plus grid size y, and start z. Okay, so this should draw some lines, basically from left to right in every y direction. So now what we need to do is we need to basically copy this and paste it down here below GL color main color. Alright, so it's basically the same thing. We're going to draw the same lines, but these are going to be for the large step, right? So this line is only going to be drawn for every large step. So if we set large step at 10, then we're going to increment these values by 10 instead of 1. So then every 10th line is going to be one of these. And the only thing that's different between these two lines is the actual color. So with all of that done, we should be able to now go into Unity. And once we're in Unity, we can actually go into and, let's see, let's set this up so that it's the main camera. we're going to just take this grid overlay and just throw this under the main camera. And we're going to show main, and our grid size is going to be 64 by 48. Our starting x is going to have to be negative 0.5. So our starting y is negative 0.5. Our small step is going to be 1, and our large step is going to be 10, I think. So we'll see how that looks. So, as you can tell, oh, our y is wrong. But you can tell that we've only got our main lines here. So we also want to show the sublines. See, that looks much better. And it looks like they all line up perfectly. So now that we have our squares like this, we can kind of play around with all these values, right? So instead of doing large step 10, let's try like a different value. Let's try 8. See, now that looks a lot better. So let me see here. We've got 1, 2, 3, 4, 5, 6, 7, 8. And okay, so see, that gives us more even squares, because 64 divided by 8, you know, is 8, and then we've got 8 squares across, right? 1, 2, 3, 4, 5, 6, 7, 8. And we've got 1, 2, 3, 4, 5, 6 squares down, which 6 times 8 is 48. It being 10 would not have evenly divided, so that's why we didn't have you know, nice lines. We can make these lines smaller, you know, with the 4, the further subdivide, or we can go bigger with like a 16 to kind of, you know, make it bigger like that. But I think the magic number here for me that looks good is 8. Sorry. Did I say 8? Yeah. You know, we could go with 12 maybe? 12 doesn't go into 64, I don't think. And now we've made Unity mad. So rather than sit here and wait for this to fix itself, I'm going to just force quit. And we're going to open this back up. And it probably didn't save any of that. Yep. So we're going to have to go and drag that stuff over again, which is why you always want to save. Every time you make a change, save it. Good size X. I'm going to go with 64. 48. Start X is negative 0.5. Negative 0.5. Did it again. Negative 0.5. And small step is going to be 1. Large step is going to be 8. I'm going to try 12 again. Oops, we don't want to add component. Let's click start. Yeah, see, 12 doesn't go into 64 nicely. So that's why that doesn't look so good. So we're going to go ahead and make it 8. Just so that no one's OCD, like... Yeah. So that's that. You know, we can go like a little step further here and play with these colors. You know, keep in mind that whatever you do in here needs to be saved. Oh wait, so that's this color. We've got the main color here, blue. See, that looks cool. I like that. I don't know. So you guys can play around with that. It's not something I'm gonna sit here and play with for too long. But basically, let me go over these values really quick, the reason why we set them the way we did. Number one, the grid size X and Y. I got those from our game class because that's what we set our actual grid to. And these grid sizes are in units, okay? So they're not pixels. Remember, we're still doing 1024 by 768. And remember that we're using, I think, 16 as our pixels per unit. I think that's what we decided on. Yep. 16 pixels per unit. And the reason that we come up with all this math here is because 64 times 16 will give us 1024, and 48 times 16 will give us 768. So if we keep this resolution here, 1024 by 768 for our game screen, then our grid size to fill in the entire screen should be 64 by 48. The reason that we're starting our grid lines at -0.5 and -0.5 is because our cells actually get placed in the center, okay, instead of the bottom left. So we need to compensate for that and move our grid. Then the only other values we have here again are the small step and large step values. We already went over this. The reason that we did large step 8 is because 8 divides nicely into 64 and 48. We could use a smaller value or any multiple of 8. So we could do 16, do 32. Nope. 32 does not go into 48 evenly. So 16 is something you can use. 8 or 4, 2 will also work. And obviously 1, which would make no sense. And then you've got the colors. So that's really it. The next video is basically going to go over getting mouse input and basically drawing or setting cells to active when you click on that. And then not just that, we also are going to probably work on stopping and starting the simulation, because right now, once we start the game, the simulation starts, and trying to edit the simulation while it's running could be, well, it would be extremely difficult, because if you just draw one dot in the center and has no neighbors, it's just going to die right away. So you will have no chance at creating any kind of pattern that's going to do anything. So we have to figure out how to make it stop. So we pause the simulation, then we draw, then we start the simulation. So that'll be the next video. Hopefully you guys enjoyed this. I hope you guys got something out of it. And remember, if you like the video, give me a thumbs up. Comments go down below. Don't forget to subscribe. Check out my Patreon. Patrons are always welcome. I post source code and everything there, all the files and assets for you guys to grab. So check that out when you get a chance, and I'll see you guys next week.